So we've got 5 forces that we need to think about when we draw the force diagram. And then the question that you were asking me is about F equals ma and how we know what forces go in the F of F equals ma, and that's a really, really good question. And this is a relatively simple demonstration of it. So here's our force diagram. We are going to go through the 5 possible forces that we're going to put on. Weight, always, always, always there's weight, and it goes straight down towards the centre of the earth. If this was on a slope, I would recommend that you don't do it going down towards the centre of the earth, because we're never going to use that like that. Because when we do our F equal MAs, you'll see the forces that we want are either going to be forces under here, which that mg is not, or forces under here, which that mg is not. So whenever you're on a slope, you're going to have to break your weight force up into how much it goes down the hill and how much it goes into the hill. And because they're always the same, you can just memorize which is which and go straight to that as soon as you draw the particle on the hill. So I've put them here. Mg sine theta always goes down the hill, and mg cos theta goes into the hill. Theta is the angle of the hill. So theta is that angle. So as soon as you put the weight on, don't put it on straight down. Let's get rid of that. Let's put it on straight away how we want it, which is mg cos theta into the hill. Hang on, let me move it up a bit so you can see. And mg sine theta down the hill. Always, always, always mg sine theta down the hill, mg cos theta into the hill. Okay, so that's weight. We've done the weight on our little Lizzie and her sledge. Now the normal reaction. Now the normal reaction and the friction, these two, we only need to think about these when we've got something in contact with the surface, which we do here. The normal reaction is always perpendicular to the surface. So if I was on a slope, my normal reaction would go like that, perpendicular to the surface. And then the friction, now this is obviously the more difficult one. We have to answer 2 questions about the friction. Question number 1 is what direction is it going in, and question number 2 is how big is it. Question number 1, which direction is it going in? It's always parallel to the surface. So for us, it's either going to go that way or that way. Has to be parallel to the surface. If we were on a slope, then the friction would either be going up the slope or with the weight down the slope. One of those 2. But we still have to work out which one it is. So, direction. If it is moving, the friction goes in the opposite direction to the motion. Lizzie and her sledge are moving, they're accelerating to the right, therefore friction goes to the left. So that was relatively straightforward. There's friction. But how big is it? Magnitude. If it is moving, then the magnitude of the friction is mu r. Okay, it is moving. So the magnitude of the friction is mu r. Okay, so we've done weight, we've done normal reaction, we've done friction. Now number 4, tension in a string. Yes, we do have tension in a string. But that force is going to cause us the problem, the same problem that the weight caused on the slope. When we do our F equals ma, we are going to do F equal ma's, all the forces underneath there, and we are going to do all the forces underneath there. So that T, not helpful. We need to break it apart into its 2 component parts, which is going to be all of the bits going this way and all of the bits going this way. Now, one of them is T cos theta, the other one is T sine theta. The one that is T cos theta is the one next to the angle that you know. And they told us that this angle was theta, which makes this T cos theta, because the angle is next to that side. The other one is T sine theta. And then once you've got it resolved like that, we don't actually need this anymore like that. That's much better. Okay, so now we come to our F equals ma. Because there's no engine, so 1, 2, 3, 4, 5 is irrelevant. There's no engines or anything like that. Nobody's pushing anything. That's it. That's all the forces. NA. So now we do our F equals ma. We're going to do 2 F equal ma's, one for each highlighter line. The green one, which way should we take as positive? We always choose the direction of positive to be the direction of the acceleration so that we can just put acceleration in as a number, a positive number. So let's say this was accelerating up, I would choose up as positive. If it was accelerating down, I'd choose down as positive. It's actually not accelerating in either direction. It's actually not even moving, let alone accelerating up and down. So it really makes no difference which one I take to be positive. So for the sake of argument, I will take this one to be positive, and I'll say anything going in that direction is going to be positive. So r is positive, t sine theta is positive. Anything going in the opposite direction is going to be negative. Equals mass times no acceleration. No acceleration for the green F equals ma. Okay, what about the pink F equals ma? I think I need to move the question. So this is AQA, I'll put it in the description, it's AQA 20, I've forgotten, 2019 I think, I'll put it in the description. Okay, so now our pink F equals ma. So this particle, this Lizzie and her sledge thing, they're accelerating to the right. So they're accelerating that way. So anything that is under that arrowhead is going to be positive, and anything under the other end of the arrow is going to be negative. So the t cos theta is going to be positive, and the mu r is going to be negative, and that will equal the mass times the acceleration. And then sometimes in these questions they give you some information. They tell you maybe t or theta or m or something. What you've got now is two equations. And what is going to happen in every single F equals ma question that you do is that you will do F equals ma, maybe even F equals ma again, simultaneous equations. So in this question, it looks really hard, but it's just the same as it always is, which is draw the force diagram, think through the 5 forces, be careful with friction, do F equals ma. Well, we resolved that one so that we could do our F equals ma's, that one and that one. Put the head of the arrow in the direction of the acceleration, or in either direction if it's not accelerating. F equals ma, simultaneous equations.